Okay, so welcome back. This week we're going to be discussing Lesson 4, Working with Disks and Devices. This lecture today is going to cover the exam objective 2.1 for your 70-687 exam, which deals with configuring devices and device drivers. Today we're going to look at installing, updating, disabling, and even rolling back drivers. We're going to talk about, in cursory terms, how to resolve some driver issues. We're also going to talk about configuring those driver settings, and also we're going to elaborate on what is a signed driver versus an unsigned driver, talk about some of the methods they do that, and we're going to also talk about managing driver packages. So let's get started. First and foremost, we probably need to talk about device drivers. A device driver is, for those of you who had me in NOS 110 and probably remember some of our lectures, it is a layer, it's a software layer that allows the operating system to communicate with the hardware. Historically speaking, early operating systems, going way back 20, 25, 35 years, operating systems were designed with the hardware, or a majority of the hardware, rolled into the kernel. That created some significant issues. For one thing, hardware vendors had to come out with hardware for each different type of operating system, which meant that when you went to the store to purchase a video card, they would ask you, well, what operating system are you installing that card for? And you would say, well, it's going to be for a Linux system. And they say, well, here's the Linux hardware. And you say, well, here, actually, no, it's a Windows system. And say, well, this is the Windows hardware over here. And better yet, are you running, Windows 3.1? Or are you running that newfangled Windows 95? Because we have two different types of hardware available for those. So that became kind of an unruly and difficult minefield to navigate. It was difficult for vendors because it costs a lot to produce that hardware as opposed to software. And for users, installing hardware was difficult, and you had to oftentimes wait for the latest operating system rollout in order to upgrade your hardware drivers. So it didn't take long for software developers to realize that they had to come up with a better method of communicating with hardware. So they came out with a modulated approach to device drivers, where instead of rolling the device drivers into the operating system, they would allow device drivers to be standalone, so that you could, as a vendor, you can make one video card, but you could have someone write device drivers for both Linux and Windows and whatever, and then you would sell the same card. You would just include a different disk in that card to install that device. This was a much simpler approach. It's an approach that we use today. Furthermore, back when Windows 3.1 was out and you purchased a piece of hardware, it would take sometimes all day to install that hardware. Each piece of hardware communicates with IRQ settings and memory addresses, and certain memory addresses can't be associated with two different types of hardware at once. They all have to have a different IRQ channel to send interrupt requests to the CPU, so that they know when they need to talk to the CPU. And you couldn't have conflicts with those, and you had to manually resolve those conflicts. We don't have to do that in Windows environments anymore, because we have plug and play. Ever since Windows 95, the plug and play feature has gotten exponentially better, and in Windows 8, plug and play is probably at its all-time best. Rarely do you have to worry about installing a device and having to manually configure it, or trying to resolve any significant issues with that device. It's just very difficult to find examples of that anymore. So we've come a long way with device drivers. But still, occasionally you have to troubleshoot device drivers, and occasionally they have to be updated, and there are some security concerns with device drivers, and a lot of our lecture today is going to focus on these types of things. So back to the original question of what is a device driver? Well, a device driver is used to communicate with the operating system running on the computer. Each device requires a software element called a device driver. Doesn't matter if it's the keyboard or mouse, and those device drivers are pretty much standard and you never even think about device drivers for those devices, but they are there in the background running. And if you ever put a specialized keyboard in for whatever reason, maybe you have a user that has special needs and you have to purchase a special keyboard with some additional functions, you'll realize it comes with device driver disc because the standard keyboard device drivers are not designed for that specific keyboard. So every device on the computer, from the hard drive to the mouse to the video card, the way the buses interact with each other, they all have drivers that help run those devices and communicate with the operating system. So, device driver provides the operating system with information about each specific device. And we can see what information it provides by going into the property sheet, for instance, for a printer. And that's going to include some generic system information. If you go into other tabs, such as the Device Settings tab, they're all going to be based specifically on the hardware information provided by that device driver. Alright, so this, for instance, is a color printer property for the Device Settings tab for printer's property sheet. And as you can see, there are some PostScript memory settings, output protocols in ASCII. It has timeout weights and things like that pre-configured, and you can see that in these property sheets. Alright, so major part of Windows 8.1 installation process consists of identifying the devices on the computer and installing the appropriate drivers for them. When this works, it works beautifully. If it doesn't work, you have a headache. So when we talk about installation of operating systems, or in NOS 110, we talk about installing or upgrading operating systems. One of the things I always mention is be sure to have, whenever possible, the updated drivers, in a disk somewhere for the operating system, not only the operating system you're upgrading to, but the one that you upgraded from, so that if you ever have to roll back the operating system, if the operating system install fails miserably and you have no other recourse but to install the old operating system, you have those drivers available. So, always important to have, particularly in instances where you think that the device drivers may not have been shipped with the operating system, be sure to go ahead in advance and make sure you have the updated drivers for all those through the vendor. Alright, so as part of the installation process, it is vital that the Windows operating system correctly identifies the devices and installs those drivers. The Windows 8.1 installation package in and to itself includes hundreds of drivers from many different devices, which is why many of the installations finish without any intervention from you. Now, sometimes you're going to have to supply those device drivers yourself, and that's why I ask you to get those in advance, particularly if it's something that you think might be unusual. Okay, so let's talk a little bit about understanding the driver complexity. As I said before, virtually every component in a PC requires a device driver, and those device drivers, depending on the hardware, will vary in complexity. As I said, the keyboard and mice drivers, are very simple in comparison to, say, graphics adapters. Graphics adapters in and to themselves are self-contained computers. Today's graphics adapters have their own processors and their own memory. There are a couple things that we think about when we start classifying drivers by level of complexity. One of which is, how often do we think that driver is going to be updated? Drivers that do more things, that have a lot more features tend to have a lot more problems, and because of that they tend to have a lot more driver updates associated with them. There are devices that are inherently not going to be or have their device drivers incorporated in the operating system, or less likely to have those drivers incorporated in the operating system, and we think of those as more complex drivers. And of course, there are device drivers out there that tend to cause more compatibility or functionality issues, and those add another layer of complexity to the device driver environment. So those three things help contribute to what makes a driver more complex compared to some of the more simpler drivers. A mouse driver, this optical mouse right here, it pretty much operates like any other optical mouse, and therefore the drivers for this work pretty invisibly. We don't even think about the device drivers for those. It's a very simple process. Graphics adapters, being self-contained computers with their own processors and memory, and oftentimes with a bunch of features. Printers, all-in-one printers. All-in-one printers have a wide variety of features built into them. The device drivers have many layers laid on top of each other, and they become very complex drivers to troubleshoot. So just bear that in mind, that depending on the type of hardware you're going to be troubleshooting, there's going to be some drivers that are easy to understand and some drivers that are going to be much more sophisticated and require some additional troubleshooting steps. Okay? Alright. Now, keeping up with drivers for all devices can be difficult. And so we have to consider whether we're going to install, or whether or not installing each driver update that comes out for those drivers is either necessary and or safe. Now, there are reasons why vendors release driver updates. First and foremost, driver updates are designed to fix problems or plug some sort of a security hole. This is probably the leading reason why you should think about upgrading a driver for a device, particularly if you're having some sort of issue with that device. So when a vendor comes out and says this device is, we've experienced these types of issues with this device, or we have a zero-day exploit that's being attributed to some sort of a hole in the device driver, this is something that you would prioritize as an administrator for rolling out that new updated device driver. There's some other reasons why device drivers come out. They oftentimes implement new features and or they enhance the performance of a device. This is not necessarily a priority reason to update a device driver. If your devices are working fine for your users or for yourself, and you don't see any specific benefit the new features will have for that device, then updating that device driver is not necessarily something you want to consider. Regardless of whether you decide to update a device driver for new features or not, or whether it's going to patch a security hole or not, the one thing I have to express is that it is always important, particularly if you're working in a production environment or a corporate environment where downtime is critical, that you test all the driver updates before you deploy them. This is especially true, like I said, in a corporate environment where you may roll out a device driver that affects hundreds of users at a time, and if you haven't adequately tested that device driver in some sort of test environment, whether it's a virtual test environment or some sort of hardware environment you've set up for yourself to run those tests, you run the risks of crippling those 100 or so users until you either roll back those drivers or find some sort of a workaround. This is not necessarily conducive to long-term employment. So, always, just like rolling out an operating system, you need to have some sort of a test some sort of a test bed for rolling out new drivers, and you need to have a testing process in place that allows you to roll out drivers as soon as they are released, but at the same time it gives you the flexibility to actually run those tests and updates. Another thing about releasing device drivers is if device drivers come out and it's not imperative, if it's not plugging a security hole or patching a problematic device, then you might want to wait a week or 2 weeks before you decide to use or roll out that driver. And I'll tell you why. Because depending on the vendor, they may not have adequately tested that device driver on a wide variety of hardware. So it's probably a good idea, if at all possible, to let that wait a week or two and read the forums affiliated with that vendor and see if people are reporting issues with the latest release of those device drivers. Why? Because that will give the vendor some time to fix those device drivers, and therefore saves you a little bit of headache by rolling it out, going, oh my gosh, it broke this, this, and this, and then you got to contact the vendor, and then the vendor has to work on it. Let someone else do that dirty work for you, and wait as long as you can. That's prudent to roll that device drive out to your users. Okay. All right. So, what is driver signing? Well, a signed driver is a device driver that includes a digital signature. A digital signature is just a value. We call that a protected checksum, and that is a value of an algorithmic function that is dependent on the contents of the data object and that is stored together with the data object. So, what does that mean? It means that, let's take a device driver for instance. I build a device driver and I run an algorithm on that device driver, and it's going to generate a numeric value for that device driver based on the contents of the coding in that device driver. Now, if I change any coding in that device driver and I rerun the algorithm, I would come up with another numerical value. And because of that, if I take that numerical value and then I run it and hash it out, I use my private key to encrypt that value so that it can't be changed. I can sign that driver so that if anyone tampers with it, it will change the checksum and it will show up as an altered driver. This provides an unparalleled level of security when it comes to installing drivers. Windows 7, Windows 8, 8.1 won't even by default allow you to install a driver that is not signed. So, because of that, there are instances when we may have to bypass the digital signature requirements. And we're not going to go into how we do that in Windows 7. In Windows 7, we used to hit the F8 key, and we'd go in and change, one of the options was change to, bypass digital signature. Well, we can't do that in Windows 8. It has a different method for modifying the boot options because, quite frankly, they have streamlined the startup process in Windows 8 so much that that's just not feasible. So, Windows 8 has a different method for modifying those boot options. So, what do we do for accessing the advanced boot options? So, in order for us to actually go in and change or bypass the digital signature requirements, we have to go into the update and recovery screen. We refer to this as the startup recovery screen in Windows 7. Startup recovery does not work the same anymore. So we have the update recovery screen, and in order to do this, you actually boot into your Windows environment. You take your mouse, you put it all the way to the far lower right hand corner of the screen until the Charms menu shows up. Once that happens, click on Settings, and change the PC settings, and the PC settings menu will appear, and then select Update and Recovery. And once the Update and Recovery screen launches, then you're going to want to select Recovery. Once you've selected Recovery, under Advanced Startup, choose Restart Now. Once you say Restart Now and the computer restarts, you're going to see a screen that looks like this. So, once you get to this screen, you're going to select Troubleshoot. And once you get into the Troubleshoot screen, then you're going to have the ability to go in and change these advanced options. When you get into here, you're going to say Startup Settings, and then once you get into the Startup Settings menu, you will see this screen appear, which will allow you to debug, enable the boot logging, and go in safe mode, go into the driver signature enforcement, and of course that's where you want to be, is to disable that driver's signature enforcement. This will allow you to install unsigned drivers. Now, this is buried way deep into the advanced boot options. This is much more difficult to do than pressing the F8 and choosing safe mode, but it will still let you go in and do safe mode, driver signature enforcement, and one of the interesting things in here is it will let you disable the early launch of anti-malware protection, for instance. So this is an important process to be aware of, is being able to find the startup and recovery screen and restart into the advanced settings, and go into the troubleshooting settings, because this is where you'll be able to troubleshoot a large percentage of your startup / driver issue problems that you may have. Alright, now hopefully you didn't try to follow along on your Windows 8 machine while I did that, but I will post a video on how to do this, so you can look at the video in this week's lesson and follow along, and it will show you step by step. Okay, so that's how you would go in and disable your driver signature installation process. Now, so working with devices, most PCs use a universal serial bus USB connections for peripheral devices these days. Back in earlier days, we used serial ports, we used parallel ports. Most of all of that today has been replaced with USB. Plug and play is now an integral part of the USB standard, so when you connect a USB printer or any other USB device to a computer running Windows 8, the system is going to 99.95% of the time detect it. It will add it to the devices and printers control panel, and it will install the appropriate device drivers for it with very little intervention from you. So when you're said and done, you'll end up with a screen like this with the devices and printer screen, and here you can see that there are, there's a fax, there's really nothing here that's plugged up except the generic non-PNP monitor. But as you add your peripherals, they are going to show up in this screen. All right. You can indeed add a device from a manual perspective. This screen, which is found through the Added Device Wizard, will take you in and allow you to do a manual configuration, a manual addition of a device to your PC. Now, there are some conditions when a device will not install. When this occurs, one of three things is going to happen. Either the installation program will recognize the fact that it does not have the vendor specific device driver, so instead it will find and match a generic driver and install that as a substitute. Or the installation program will leave the device without a driver and it will complete the installation. Or if it can't do that, the installation program will permit you to supply an alternate driver, or failing that, it will stop. Updating drivers with Windows Update. Windows Update website was originally designed to provide users with operating system updates. But now, with the whole driver signing process being very important for driver security, Microsoft Windows now includes a large library for device driver updates. If Windows 8.1 is configured to do the automatic updating, the system is going to download device drivers only for hardware that it does not have a driver installed for by default. Okay? So, if you want to install an updated driver for a specific piece of hardware, you can do that through the device manager, and we'll talk about that momentarily. Managing driver packages, the collection of all the software components needed for a device to be supported in Windows 8.1. We call that a driver package. And apart from the driver files themselves, the driver package will include like an installation program, like a setup information or INF file, or a driver catalog, which we refer to as a CAT file. And the package might also include, things like property pages, install wizard pages, icons, utilities, and so on. All this can be rolled into what we call a driver package. During the life of a Windows 8.1 installation, the system is going to typically download and install multiple versions of these device driver packages over time. And these driver packages will add up. So there'll be multiple versions on your system, and they'll begin to occupy a lot of disk space needlessly. So to eliminate these, you need to locate the outdated driver packages. You can run what we call the disk cleanup application. This is an example of the disk cleanup application. This allows you to go in and actually tell it what files and programs and stuff you want to remove from your operating system that are just kind of cluttering up stuff. Okay? So what happens when you select device driver packages in disk cleanup? What exactly does it do? Well, it looks for device driver packages that have been superseded by a newer set of drivers for those specific packages. It will recognize that those packages are older, obsolete drivers, and it will add that to the list of files to clean off the system, thereby freeing up some additional space on your Windows root media. Okay? Now, as far as managing driver packages, the setup program is going to will copy the files for all the included driver packages and operating system components from the installation medium to a directory that we call the WinSXS, the side-by-side component store. This will enable you to add devices later and install the drivers without having to supply an installation medium. Now, there's a problem with this, and that is that the Win, we'll just say side-by-side instead of XS directory, also occupies a significant amount of disk space. So, you can't just delete this directory to reclaim the space, because many of those files in the side-by-side folder are going to be hard links. Now, if you've taken Linux, you know that a hard link is mapped to locations in system folders. They are parse and parcel with multiple links on a piece of storage medium, so that even if you deleted one of those references to the file is not going to go anywhere until all of those hard links are removed. All instances referring to that file are removed. You can't delete it. So, fortunately, Windows 8.1 includes what they call the Analyze Component Store parameter for deployment, image servicing, and management. Okay, we call this tool, I call it the DISM tool, dism.exe. It will enable you to analyze the Windows Component Store for driver packages and other files which can be deleted. Now, to use this, you're going to have to do it in the command line. You're going to have to use this parameter through an elevated command prompt. That's a command prompt that you are running with as an administrator. And the command is dism/online/cleanupimage /analyze component store. You can initiate a cleanup using the disk cleanup tool or this following command that you see here on the screen. Either one will work just fine. When you run the disk cleanup tool, you'll end up with a command prompt. If you run it through the command prompt, you're going to end up with a summary that looks very similar to what you see here on the screen. Okay? Alright. Using the device manager. Just like previous incarnations of Windows, the primary tool for managing devices and their drivers is the device manager. You can use the device manager to get not only information about the devices that are installed in the computer, but you can use the device manager to do installs, to do device driver updates, and of course to troubleshoot device drivers for your system. This is a sample image of the device manager, and as you can see, it encompasses virtually all of the devices that are on your system, from the disk drives and display adapters to your rudimentary floppy disk drives, network adapters, monitors, processors. Yes, processors do have device drivers, and of course any other USB or COM or printer ports are also represented in the device driver. Now, if you want to see the properties of a specific device, well, the device driver is capable of doing that. It can do it in the following four modes: by devices by type, devices by connection, resources by type, or resources by connection. The device manager property sheet has these tabs on their property sheet. That's the General tab, Driver tab, the Details tab, the Events tab, and the Resources tab. So the General tab, this is where you get the general information about what the device driver is, who made it, where it is on the system. The Driver tab will show you the driver's provider, the date, the version, and this is where you do those important rollbacks or updates. They can all be accomplished from the Driver tab. The Details tab displays, well, extensive information about the driver properties in significant detail. And if you want to look for specific you're doing troubleshooting, you want to look for events related to that driver, that's where you'll find it in the Events tab. Last but not least, the Resources tab. Well, the Resources tab is going to show you all of the resources that are going to be affiliated with this driver, and will show you if there are any conflicts associated with any of those resources. So, this is what it would look like if you opened up a specific driver property sheet. So what do you see here? This is the PCI Bus Master IDE controller driver, and we are in the General tab. And we can see that it is an IDE ATA controller. It is made by Intel. Its location is the PCI Bus 0, device 7, function 1. It says it's working fine. We can actually dig further by going into those tabs and looking at specific events, looking at the driver details. Maybe we'll find out in the driver that the version is out of date, and we can actually go into the Driver tab and update this driver. Or maybe we discover that the last driver install that we put in is not functioning correctly, and we can do a rollback to roll back to the earlier version of the driver and see if that's going to work better for us. Alright, now enabling and disabling drivers, I can do this in the device manager as well. I can disable any device in the computer using any of the following procedures. So I can either select the device and then choose disable from the action menu. I can right click the device and choose disable from the context menu, or I can open the property sheet and then click the disable button on the Driver tab. You will find that in the Windows world there's usually 3 ways to do anything in the operating system, and disabling devices is certainly not an exception to the rule. Alright, I update drivers. I do this through the device manager as well. I can point to a location on the computer where you've already saved that new driver, and then I could also run a search on the computer and the internet and find the driver that way and do a driver update. So, updating the device driver, I can do that through going in. I have two choices. I can search automatically for the updated driver software, or if I know specifically where I've saved that driver or I have a driver's CD available, I can browse to that location and point to it and install it that way. Okay. Once I find the location, in this case it's actually on a network share in server A root administrator documents, I can then begin the install or process of that driver update. So rolling back drivers, so it's not totally uncommon for new drivers to cause more problems than they fixed. And so many users would say, well, curses, if I knew that, I would have installed the driver to begin with. Well, we have an option for that. We've had this option actually for several incarnations of Windows operating systems, so it probably comes to no surprise to you that you do have the ability to roll back drivers. Rolling back drivers to the old version helps eliminate some of these issues that occur when you install a new driver and you just realize it's just not working out. You don't have to totally uninstall it and go back and find the old driver. It will keep tabs on that for you, and it will in most instances allow you to do a rollback. The rollback feature, which you initiate simply by clicking the rollback driver button on the driver tab of the device's property sheet, will begin that rollback process. Okay. Needless to have a discussion about troubleshooting. First of all, to troubleshoot hardware or driver problems, we need to consider some of these techniques that are listed here. First of all, if you find that you have installed a printer or something like that and you're having some issues, one of the things you can do is go into the property sheet for the device, check the device status box in the general tab, and if you see the device is malfunctioning, then it's going to inform you of its status and it will allow you to launch a troubleshooter. Okay. Another thing you can do is you can open the device manager and you can delete the device entirely. Restart the system, allow Windows to redetect the system, and install the device all over again. Another option that's available to you for troubleshooting devices is if the device or driver malfunction is preventing the system from running properly. Say for instance a bad graphics driver, as is pointed out here in the lecture. That's going to prevent an image from appearing on the screen. So you can start the computer in safe mode. That's by going into the advanced boot options procedure and try to recover your driver that way. So let's sum up. Device drivers are components. They're software components that will enable applications and operating systems to communicate fluently with hardware devices, and that every hardware device has some sort of corresponding driver associated with it, even though for a lot of them we may not think about it just because they work so darn good. Plug and play, this is the standard today. It enables computers to detect and identify hardware devices automatically. It will install and configure drivers 9 times out of 10 automatically. Plug and play will dynamically assign hardware resources. Remember going back talking about this IRQs and memory addresses. It takes care of all of that for you, and it will accommodate each component's special needs. Device drivers are included when they have been digitally signed to ensure that they have not been modified since they were published. As a matter of fact, ever since Windows 7, you have to sign by default. You have to install digitally signed device drivers unless you want to go in and turn off or override that policy. In the old Windows 7, that was using the F8 command, but in Windows 8, that is really buried deeply in the troubleshooting tools in the startup and the recovery features. So, device managers. A device manager is just another MMC snap-in. And it's going to list all the hardware devices in the computer and indicates problems with any kind of hardware identification and driver configuration using the device manager. Now, using the device manager, I can enable, disable devices, I can update devices, I can roll back drivers, I can manage the device, I can troubleshoot the device, and I can look at the device driver properties and compare, say, my drivers with other drivers to see which one's the newer driver and whether I want to do a manual install of it. As far as troubleshooting goes, we talked about a couple things we could do. We can go through the device driver and we can actually run the troubleshooter if it detects a malfunction for that device. The troubleshooting wizard will run us through a list of options to help troubleshoot us with that device. If that doesn't work, or it's not an option that's available directly through the device manager, we can always try doing an uninstall and go in and uninstall the device completely and do a reinstall of the device driver and see if it will take the second time around. And of course, if you have some sort of catastrophic issue where the operating system is not functioning correctly, if you can get the startup and recovery to go in and go in through the startup and recovery and do your device troubleshooting that way through safe mode, that's also an option for you as well. So that sums up lesson 4. It's kind of the down and dirty version of lesson 4. And next week we're going to talk about lessons 5 and 6, which deals with installing applications from the apps from the App Store. We're going to look at accessing applications and hardware, and we're going to talk about that in some detail. So I will chat with you next week. Thanks a lot, and bye-bye.